So, hi everyone. Maybe someone can indicate if they can hear me. Okay, great. Thanks very much. This is Upmanu Lal at Columbia University. I'm welcoming you to the seminar today in our series on America's water. I'm pleased to have Dr. Jim Dobrowolski present today on the national water priorities for USDA-NIFA and how they are doing. Given that many people are working on the infuse proposals, which are due shortly for NSF and USDA. This may be of particular interest to a lot of people. Jim and I go back to our common time at Utah State University in the 80s and 90s. And Jim is a program leader for USDA, national program leader for developing a systems approach to water availability, looking at a broad variety of landscape issues, including agriculture and beyond. He's worked in this area for many years, both in the field through extension and as well as teaching and research. So it's not a surprise that he ends up in the role that he is in now. There's probably not a person who knows as much about the intersection of these areas uh, in the country at the moment. So I'm very happy that he agreed to present this to us. Um, and let me turn it over to you, Jim, and see if we can get things going. Usually, what we do is we type in questions on the side as the speaker is going through, and then we can address the questions after the seminar is over. Thanks very much.
Very good. Thank you, Manu. Can everyone hear me? If you can, could
Yes.
someone type in and say yes? That would be great. Um, it's a beautiful March 1st in Washington, D.C. The sun is shining, and looking out over the Washington Channel and the Potomac, I'm reminded that I've been the national program leader here at the National Institute of Food and Agriculture for 10 years. Pretty amazing. Time has sure flown by. So you're going to have a special treat today because I'm going to flip the tables a little bit. I'm going to provide you with a background of how we go about designing the priorities for a request for application, where those priorities come from, and how long it's been that we've been working toward laying out these priorities, and then allow you to kind of give me a bit of an examination at the end to let me know just how we're doing and whether or not you have some alternatives that you can provide me and we can move forward from there together. So the title of my talk is Are USDA NIFA National Water Priorities Meeting Their Mark? And welcome. So we know that there are a lot of really important problems out there. And these these problems, often Sunny Ramaswamy, my director, and many of you may know Sunny from Purdue or Iowa State or Oregon State, he often calls these problems wicked problems, and the economists actually have pretty tight definitions for what a wicked problem is. But for me, it's a problem that is often generational, often really difficult to solve, and takes transdisciplinary activities where everyone has to come together with the same mental models and the same attitudes to be able to come up with solutions that may take more than a decade to come to pass. And so when we think about some of the problems that roll out, particularly when if they're related to agriculture, producing more food with less water and adapting to climate change is one of them that is really making agriculture and ecological hydrologists very worried for the future. Also, that people centered technologies, we need more of those where we have strategic linkages between biophysical and socioeconomic information, where we're, linking very completely and exclusively between the biophysical and the social psychological so that we can actually take these technologies that we develop right to the field and get them adopted. And then other things that are sitting out there that we just can't seem to solve are nutrients and other contaminants in water. And in some cases, our own um, conservation practices or our own conservation um, activities that we promote in USDA are actually sometimes working against us. So what does the future hold for water, particularly from the USDA perspective? Well, we have a new program that we rolled out in fiscal year 2014 called Water for Agriculture. It's science, it's education, it's extension outreach, and the portfolio engages knowledge and technology, incentives, and policies to promote appropriate decision making at a wide range of scales. This Water for Agriculture addresses critical water issues, drought, for example, obviously linked to climate change, but also excess soil moisture, flooding, availability, and when I talk about availability, I'm talking about quality plus quantity. And the human dimensions of water technology adoption in an agricultural context. Well, this rollout of this new program, Water for Agriculture, it's not something that came quickly. I don't know how many of you remember, but we began this journey looking at water across the country when we were called the Cooperative State Research, Education, and Extension Service, CSREES, which was quite a mouthful. Now we're the National Institute of Food and Agriculture, which is much easier to say. But we kicked it off in 2001 with a competitive program that was really focused on providing money to promote national facilitation grants. In other words, taking good, solid extension activities and ideas that were very successful in the regional context, and then making them national, of making them available for everyone to adopt. And we had watershed level grants. It was really kind of our first cut to push people into that scale, taking us up from the plot scale into the watershed scale. And then we also had regional coordination across the country, linked in with the EPA regional groups that were at that time, that existed at that time. So this was a long time ago. This was 2001, and here we are 2014, just rolling out this big push. So back then it was funded at $12 million. It was called the National Integrated Water Quality Program. And they brought me in as a consultant, kind of. It was called a shared faculty position. It was a 20% shared faculty. And we were working through how did this program need to be and what needed to change. And during the early parts of that 2000s, we worked out some of the kinks and how it was going to work and who was going to do what and what part we were going to emphasize. We emphasized and focused on water quality in a big way. And by 2005, the agency brought me in as a half-time IPA, which is called an interpersonal agreement. It means that I was working part-time for, at that time, Washington State University, 50%, 50% for USDA, and actually located in Washington, D.C., with an office in the National Institute of Food and Agriculture. And during that 2005, we came up with a new initiative called the Agricultural Water Security Initiative. And we came up with 6 broad areas that were identified where we thought that USDA could actually make a difference. And those included water marketing, economics and distribution, water reuse, general water conservation, irrigation efficiency, drought risk assessment and drought preparedness, and biotechnology. In other words, trying to develop the right plant with the right for the right place with the right water. And we worked that through this National Integrated Water Quality Program that began in 2001. And we produced these kinds of maps. These were really colorful maps that showed either the problems, the issues, or it showed some of the solutions or next steps, bold steps, but they were really developed to give to Congress because they laid out in one page everything that we wanted to say to folks in a very colorful manner. And when we delivered these to the folks who were working for the different members of Congress, they really liked the colorful piece of this, the fact that there was a lot of really good information packed in. It was a very positive, proactive way of delivering information to members of Congress and their staffers. And in fact, when we went back later, years later, sometimes we would find these maps still up on their bulletin boards because they were quite artistic and they conveyed a tremendous message. And the message that this one was really conveying, this was our interventions map. This was what we were thinking that USDA could do. So in the middle of this map is a road, and on the bottom of the map are dead ends. So if you look closely, and you can blow this map up later or what have you, but you'll notice that there are little diamonds, little yellow diamonds that say dead end. And so all those things that were down below there were things that we thought that USDA really shouldn't intervene on at the time because they really felt like they would be dead ends in the end. And one of them, believe it or not, was desalination. So we thought, well, we'll just kind of let desalination go because back in 2005, the experts in desal were telling us that they could maybe only get about a 10% improvement on efficiencies and what have you, and maybe not a lot of price change, and the cost situation was going to be an issue, and they've beaten the heck out of that. So that was actually something that would change, would actually move up into the upper part of the map. So the upper part of the map, going from left to right, from water reuse to biotechnology, shows what we were thinking in 2005 as to what USDA might be able to do. And so during the next few years, we tried to implement some of this work as part of the Ag Water Security Initiative. And part of that was the Conservation Effects Assessment project. And some of you may have been working on these SEEP projects. We actually at NIFA funded the competitive side. We funded work in cropland watersheds as well as grazing land watersheds to look at the efficacy of our conservation programs to see if we could understand if they actually worked or not. And it was really focused on retrospective studying. We developed a lot of new criteria. We refined a lot of modeling. A lot of that modeling went into the modeling that's currently being used to evaluate our ability to improve on the nutrient fluxes that go into the Mississippi River, for example. That whole watershed, a lot of that modeling that is going on there from a nutrient perspective was developed during this SEEP activities. So in 06, we had these 13 cropland watersheds. In 08, we had 4 grazing land watersheds. In 09, we funded a SEEP synthesis. And what did we learn from that synthesis? Well, we learned that conservation practices actually do work. The gains have been made in some cases, but critical conservation concerns still exist. That we have to do things comprehensively. We have to look at things as systems rather than single practices. And we have to target critical areas, and that improves the effectiveness. And you can take a look at the report, the HTTP. The URL is sitting right there for you, and it was compiled by a large team, put it together, led by Deanna Osmond, and her team out of NC State. So take a look at that when you have a chance. Okay, we also, during the time from that 2005 initial development of the Ag Water Security Initiative, we started talking about water reuse in agriculture, and we held some really stimulating specialty conferences with the Water Reuse Association. In 2006, we offered one that was called Opportunities and Challenges. It was a workshop in Santa Rosa, and it was really focused on trying to link up the municipal wastewater treatment folks with agriculture and get them to kind of tune into the fact that agriculture could be one of their customers and a big customer at that. And the other one in 2008 was really looking at ensuring food safety, and that workshop was in Monterey. So we were trying to infuse water reuse into the U.S. Department of Agriculture as well. Before that, there were a few places that were working on it, most notably the Salinity Lab and Parlier, mostly focused on ARS facilities, and areas, some of the areas in Arizona. But really, there wasn't a lot of push and shove associated with looking at non-traditional water sources like recycled water from wastewater. And so when we kicked this off, we had a very large group that showed up for these meetings. And particularly when we were doing the food safety workshop, because when we were out there, we intended on having about, I don't know, about 60 people show up so we could have it pretty closely controlled and have really good breakout sessions so that we could develop some information to move things forward and some strategies to and bold steps for how USDA could move forward in recycled water. And then the spinach issue occurred, where they had the spinach contamination and people got sick and it became a national issue. And we went from 60 people to 300 people, and the national news showed up for the whole thing. So it was quite exciting, but it was also very stressful. But it was really, it kind of put us on the map for some of these things. Now, the interesting thing is that although it put us on the map, things moved on. Um, Agriculture is a big user of water, obviously. We control about 80% of the water that is used in the United States. We the agricultural production machine is an important part of the usefulness of that water and where it goes and how it gets here and there and who uses it and who doesn't use it. But it's amazing how fast things change. And so although there were areas of the country that were very focused on delivering recycled water, treated wastewater to agriculture, as soon as municipalities were able to produce water through using membrane systems or what have you, and disinfection, to the point where it met drinking water standards, they started thinking about the delivery of that water as custom water delivery. So as a commodity, as something that they could deliver to industry with, really fine-tuned qualities so that industry would pay. And in some cases, big bucks for really finely developed water. And so a lot of the water thinking that was focused on maybe agriculture could be a big customer shifted to, well, maybe agriculture is not such a big customer because we have to deliver it to these farms. It costs a lot of money to do that. These delivery systems and these dual systems, these purple pipe systems, for example, they're difficult to put in, particularly in municipalities. They cost a lot of money. Maybe we'll think about delivering it just locally, right inside town. And so they started thinking about indirect potable and now direct potable. And so we had, just a few years back, we had this really nice NRC report that came out talking about what the future held for recycled water. And it was really focused on indirect and direct potable. not agriculture as the customer. So right now we're working hard to kind of, as that works its way through, we're also working to see what we can do to provide some new concepts for these folks to be able to deliver that water with shorter delivery distances and maybe cost effectiveness, where agriculture would once again be thought of as a potential large customer. So here we are. We're in fiscal 14. We've been running the National Integrated Water Quality Program for 13 years, and Congress decides and the president decides that that's going to fade out, and this new program, Water for Agriculture, is going to come in. And what happens is Sonny Ramaswamy decided when he arrived at NIFA that where's water? You know, it there was no challenge area that the president had stated and that had trickled down through the Secretary of Agriculture that was focused on water. It seemed to be a part of everything. And of course, when something's a part of everything, it's really kind of a part of nothing. It doesn't raise to the surface. It's not pointed to. It's not as exciting. You just kind of say, well, it's part of all the programs that are in the National Institute, and you go on from there. So he said, no. We're going to bring this up and raise it up to a challenge area. And so that's what he did. So he rolled this out with the Secretary of Agriculture in 2014 as the Water for Agriculture Challenge Area. And that first year, we funded nothing but these new types of funding mechanisms called CAPS, Coordinated Agricultural Projects. They were regional scale issues looking at sustaining water quantity, quality, and availability for ag use while maintaining environmental quality through 2050. We had a general concept of what we wanted people to do, and we said, show us what is your problem in your region, and we'll fund it. And so Water for Agriculture was defined as better water quality, understanding human behavior on decision making for ag water use in agricultural, rural, and urbanizing areas. That's where we were focused, not just rural areas, because for a long time USDA was just considered the rural agency, but we're pushing that envelope. We're looking at activities in ag, rural, and urbanizing areas because agriculture is being pushed into the urban centers around the country. And it funds water research, education, and economics that links food, water, climate, energy, health, and environmental issues. So this is what Secretary Vilsack said as he launched this Water for Ag. He said cutting-edge research holds the key to tackling complex challenges because of the drought and ensuring future food security. And these grants will help arm American farmers and ranchers with the tools and strategies they need to adapt and succeed, and to build on ongoing cross-governmental efforts to provide relief to those impacted by severe drought. So so we're in the midst of the California drought. We're in the midst of the Southwest drought, and there's a lot of pressure. So we roll out the Water for Agriculture Challenge Area. So what was our response? Invest in the development of management practices, technologies, and tools for farmers, ranchers, and forest owners, and to particularly link social, economic, and behavioral sciences with traditional biophysical sciences and engineering. That's a critical part of this, because we really need to address regional scale issues with shared hydrologic processes in the same meteorological and basin characteristic situations. So it makes sense, because in most cases, most of the problems in water are local. So we're collaborating domestically with the Water for Ag Challenge Area. We're working together with the National Nanotechnology Science Initiatives, developing alternatives for reverse osmosis membrane processes, water standards, and sensors. We're also collaborating domestically with what many of you are madly writing your proposals for Infuse. The overarching goals of Infuse, of course, is to catalyze the well-integrated interdisciplinary research efforts to transform scientific understanding of the food, energy, water nexus. So we're working with NSF on that. We're also working with ORD at EPA, looking at the chemical contaminants of human health concerns in non-traditional ag water. What are the nature and extents of those contaminants, and what are the human exposure pathways and health risks? We're also doing international collaboration. We're working, and we've minted a new MOU with Israel, looking at BARD, the binational agreement on research and development, and we're working with Mexico on transboundary issues focused on the Rio Grande. Other programs that still have water outside of water for agriculture, SBIR, the Small Business Innovation Research Grants, they still have $2 million that resides for water, air, water, and soil. In the Agriculture and Food Research Initiative, that's our flagship competitive funding line. We have little parts of water in food safety, ag systems, nanotechnology, bioenergy, and natural resources and environment, BENRI. So when you're looking at other programs where we're trying to promote foundational research, and those foundational pieces are supposed to be the foundation for these big challenge area grants, that's where you can find some water, about 18 million bucks. Other challenge areas like climate change and bioenergy, for example, food safety and food security, all have water footprinting as part of their activities. So the priorities that we've set out for 2015, and these are the ones I want you to kind of give me a little bit of an exam on, are one, water availability for diverse agricultural uses, the right water for the right place and time. Those were $10 million coordinated agricultural projects. Now, these big cap projects, they're regionally based. They're supposed to be transdisciplinary teams working on them, so people with like mental models working together and towards solution. Caps are really funded to push a problem or issue towards solution. The next one is understanding decisions and behaviors connected with ag and post-harvest processing industry water use. Back as far as 2005, we realized that, this behavior change and adoption piece is really a problem. We have a lot of existing water conservation technologies. We have a lot of irrigation technologies that are not used. They're not adopted. And so this was something that we needed to carry forward into the future, was trying to get people to understand what the science is behind behavior change, realizing that it might take up to 10 years to get that behavior change to actually occur. So we have 500K standard research projects. These are research-only projects that are really focused and trying to be directed at our sociological and psychological colleagues to work with biophysical folks to try and get some answers in the actual adoption and bio and behavior change activities. And the last priority is really understanding the human health impacts to exposure from non-traditional water used in agriculture. And that's our priority, where we're linking with the Environmental Protection Agency because we had similar priorities. And one of the things that the president has really pushed us to is to not duplicate efforts. And so this is one of our activities where we are working to not duplicate efforts. We're actually truly collaborating, which means we are sharing resources. And we are looking at their portfolio and our portfolio and trying to do things in a similar manner. And in the future, it won't just be recycled water and human health. It could be all sorts of different water quantity or availability activities. We also are using some interesting relational tools that are focused on what we funded in the past. So we have this thing called push graph, which is really a relational tool to show what we have funded out of all the projects that have ever been funded in both CSR, ES, and NIFA. What pieces point to water? And what are the pieces that we've done already? And how long and how much have we funded in these certain areas? How much pathogen work have we done? How much nutrient work have we done? And has it been effective? So we're using tools like that to move forward and to try and make the priorities that we put out there as exclusive and important as possible. That's not the only thing we do. We actually map the priorities to, obviously, the USDA strategic plan. We also have a USDA mission area research, education, and economics action plan that we map the priorities to. The PCAST reports, both on the U.S. research enterprise and ag preparedness and ag research enterprise, both those we map it to. We're also mapping it to a science roadmap for food and agriculture that the SCOP folks and ECOP folks from the land grants have put together. Also, our own portfolio planning document for our own institute and division. And of course, the Water and Ag in a Changing Climate Hort Science paper. Never thought I'd be publishing in Hort Science, but that's a paper that Mike O'Neill and I published a few years back. And then one that was published by a long list of folks that were the water chiefs of most of the land grants, called Advancing Water Resource Management in Ag, Rural, and Urbanizing Watersheds, Why Land Grant Universities Matter. And then AFRI and other water challenge stakeholder listening sessions, like the one we're going to have today. So, we funded some CAPs, some coordinated agricultural projects in 2014, and they're here for you to take a look at. They range from looking at drainage water issues, nutrient issues, looking at international boundary issues and groundwater issues in desert environments, through trying to develop a new adult by developing a new paradigm for educating youth so that when the youth get to be adults, we don't have to deal with behavior change and adoption. They're already ready to adopt. And then looking at Native American issues in the Great Basin, and lastly, issues looking at really different competing issues in the Tennessee and Cumberland River basins. So that's my talk. And now what I'd like to do is answer your questions as to where do you think we need to go in the future? We've got a few minutes left, so let's hear from you.
Thanks very much, Jim. I'm waiting to see if people are typing in there. This was very interesting as a history of how this program has evolved. Um, in terms of the commercial sector as opposed to the university sector, companies like Monsanto, Climate Corporation, do you see that sector as having an impact on the setting of the priorities or the uptake of the results from the research?
Yeah, I think so. Absolutely. In fact, during the time that I have worked here, I've worked quite a bit with GE Water, for example, and several other private firms. But you know, although we talk a lot about public-private partnerships, we're not as facile about actually developing those and really using them as effectively as we could, I think. And I think we need to really focus on that into the future. I think that's really where I've bounced a lot of these ideas certainly off of municipal wastewater treatment plant managers, a whole host of them. You know, I talk with Orange County all the time and San Diego County where they're doing a lot of this indirect potable and testing out direct potable and what have you. And so we've we've worked with them, and we do have some new language that was um, part of the Farm Bill, this last 2012 Farm Bill that focuses uh, the commodities in particular, their efforts on matching money with us to push awards out. But I think that's
Thanks.
something that we need to emphasize into the future,
Right.
not
I
just as
mean, the
consultants, but
related
really working
question
more
is
closely
that
with
of
them.
public and private extension services because both exist, and their relationship to the Farm Bill and the
Hmm.
Farm Insurance Program, because many people argue that you end up with perverse incentives to grow the wrong crops in the wrong regions in the US. Partly the biofuel story, but also, just in terms of how crops have moved since the farm insurance bill came up, has not been consistent with the water resources of many of the places. So, at the larger scale, do you have thoughts about the role that the private versus public extension is playing in trying to help people understand the sustainability aspects, both back to the people who make decisions on what incentives are being offered on the government side versus decisions that people are making on the private side?
Yeah, it's tough for me to answer that one because I have mixed feelings about it. I I work a lot with and encourage private extension outfits and outreach outfits because and we do fund folks that line up with them and 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 provide that service outside of the
Uh-huh.
land grant extension system. It's tough for me. You know,
Right.
I'm a national program leader, and it we do talk about the fact that we have issues. We have risk management issues and insurance issues that they're going to work against us in some cases. And we do discuss this at as high a level as we can. And I think we've made some progress in the past. But again, that's going to be something
Sure.
that you folks are going to help me with because it's really difficult for my voice to make a dent
Sure.
in that because it's
I mean,
pretty
the
much
issue
over
is
my
that,
pay
on
grade.
the research side, we are seeing that there are opportunities to really have an impact on water use from those levers that the government put together, and that's why the question came. But let's move to questions that are coming in online. Robin has a question on, is the USDA taking steps to redevelop regional food systems around the nation as a way to take pressure off of overtaxed watersheds in the West?
Oh, that's something we've been talking about, and it's, you know, again, USDA is a very large agency, and there have been widespread discussions about redeveloping regional food systems, redeploying certain crops in certain places, and I think that's one of the reasons why we have that first priority, which is, what's the best crop for the best place with the best water, so that we can actually begin to grow crops again where there are, well, that's the thing, where there in the past there's been adequate water. I can't say that the South is going to be a place where, even though we're thinking about redirecting cotton back into the South, you know, they've been under some drought stress off and on for the past 10 years. And certainly those areas are, they can be stressed from time to time. So just moving it in different places of the country may not be the answer, but it's certainly fine tuning where the right crop is in the right place with the right water, and using recycled water and trying to alleviate some of the fresh water that has been used in the past is going to be one of the solutions in the future. Okay, Kai says, while wastewater reuse is necessary for ag going forward, how high should the water quality standards be for recycled water when used to irrigate food crops? I'm thinking of untreated residues and reclaimed oil-filled water, untreated emerging contaminants. Yeah, so Kai, thanks for that question. That is one of the things that we've been um, pushing as far as trying to develop guidelines and standards that are focused on the different crops that you're going to produce. And it all depends on the source water. It depends on the crop and what it's used and the contact situation. It also depends on how close the farm workers are to this water. All those things are going to lead into particular standards and guidelines, and I have really pushed that. And I heard that loud and clear back in 2005, that we need, some standards and guidelines to do that. And I pushed for that from the national level, and I got a bit of a pushback from the states because the states felt like they had the handle on that. So California, for Title 22 and what have you, they felt like they were fulfilling that situation. But the reality is we're using recycled water for organically grown crops, and there really is very little control as to what kind of recycled water they're using. They're using best management practices, and they're using the guidelines put out in the EPA guidelines, which I wrote part of that. But is that good enough? And so that's something that we're going to pursue. Okay, Kamal. Yeah, Kamal, you've got one that says, what is being done to make sure that the irrigation system does not add positive feedback to the poor quality of the water into our major rivers? I mean, leaching and other effects. Yeah, I think that's one of the things that you're going to see us fund more into the future, is we haven't solved the salinity issue yet. And when Manu and I were at Utah State, that was a burgeoning issue, and it hasn't gone away. And so we need, like the nutrient flux issues that we're dealing with, and where agriculture is a player, we're going to have to find solutions to those wicked problems. They are wicked problems, and in some cases, market forces and cost issues and the economics are pushing things in the opposite direction. So we're really going to have to work at that. We're going to put some additional funding towards salinity in the future for sure.
There's Laurel also. Um, she's asking water markets.
Yeah, well, yeah. So Laurelyn, thank you very much. I'm working with Robin Shoemaker, who was an economist from the Economic Research Service, and then he decided he needed to come over to the National Institute of Food and Agriculture here in Washington, D.C. And he and I are scheming together to figure out what the economic issues really are, and how to actually focus attention on water markets to provide these secondary income streams to farmers. I think there's a lot of potential, and there always is potential. It's kind of like the carbon markets, though. We've got markets established, but how functional are those, and how how useful are them, and is there enough efficacy to make them function properly? And so I think they work and will work in certain areas. Certainly, they're looking at that as a possible solution in Northern California, Southern California issues. But how do we make them functional so that we can provide farmers with a secondary income stream or a tertiary income stream that would allow them to be more flexible with their water right? And it's really difficult, particularly in a state like California, where you have two different scenarios as far as water rights go. You've got the prior appropriation doctrine and the riparian doctrine working together. So it's very tough. But we're looking at that very closely into the future.
I'll ask one
Other
again.
questions?
Do you think there are initiatives within the USDA research enterprise or outside which are looking at precision agriculture as it relates to water use and specifically about data collection on how much water is being used for which crops under which climates and using which technologies? Uh, and whether or not the use of sensors and drones and things like that that people are talking about is actually effective.
Well, whether it's actually
Okay.
effective, I'll start with your last one first. I'm hoping that it's going to be effective. I'm hopeful we're actually partnering with the national nanotechnology folks to improve sensor technology and to work on using nanotechnology to fine tune a lot of the irrigation activities. Um, and and I think there is a big push on precision ag focused on sensor technology, particularly when we're talking about food crops. And there has been. There's been a lot of focus on robotics. Um, really, I don't know. I'd like to think about the future as fertilization and water. I mean, we're getting to the precision that we would literally get close to injecting it into the plant. We wouldn't have to worry about moving it through the soil or collecting salinity issues or moving selenium to the plant or all these other issues with you know irrigation through the soil or what have you, that eventually we're going to be to a point where it's really focused on delivering the exact amount of water. And it might not be like an actual hypodermic needle or what have you going down the row, but it would be something where we would actually put the exact amount of water, the exact amount of fertilizer in the appropriate place so that we don't have all the runoff issues and the redistribution issues and the pollution issues.
Okay, thanks very much, Jim. Um, any others online with questions? Doesn't look like it. So, Jim, thanks very much. This was really insightful in terms of getting an understanding of how things have evolved. Um, I, if it's okay with you, I'm going to encourage folks to write to you with suggestions as to ideas for priorities and so forth. Would
That
that be
would be
useful to
fantastic.
you?
Absolutely.
Okay.
That would be
I just saw
fantastic,
somebody
Manu.
typing
Thank you.
in, but I'm not sure if they've finished or not. There, somebody is typing in. So let's wait for one more question.
Okay.
Oh, I guess they gave up. Okay, well, thanks very much, Jim. And let's hope that
Okay.
people have ideas and can follow up with you. I certainly plan to. And thanks again.
You're welcome. And be sure, if anyone is in Washington, D.C., be sure to
Fantastic.
give me a call and visit the office.
Thanks.